The city of Padua appeared to offer Galileo all that he could desire. Renowned for its freedoms and independence of thought, it seemed the ideal place for a new beginning and a continuation of his work. Material success and professional reputation grew side by side. Now began a time of intense and fruitful work for Galileo, lecturing, teaching privately, and researching.
And amongst his other achievements, I think Galileo can be fairly described as the father of modern mechanics as we currently understand it. Now, the principle of inertia itself is relatively straightforward. Put in formal language, it states that it is the tendency of a body to remain at rest or in uniform motion until an external force is applied. In other words, what this means is, if an object is stationary, it will remain stationary until you apply an external force, say you push it. If it's travelling, it will travel uniformly in a straight line until an external force is applied to alter its direction. Say, if you roll a marble down a hill, it'll keep going in a straight line until it meets a bump or a hole, and then it'll change its direction. Now, as far as we know, this principle was first identified by Galileo and then developed by Newton later on in his first law of motion.
And still he had energy to develop a workshop for producing scientific instruments, and on top of that, designing large pieces of equipment himself. Despite this feverish activity, or perhaps because of it, Galileo took a mistress, the lovely Marina Gamba, with whom he lived for 10 years and fathered 3 children, 2 girls and a boy. The youngest girl, Maria Celeste, was sensitive and gentle, and during her life in a convent, carried out a long correspondence with her father, one that he valued greatly and which brought him comfort in some of the loneliest and most frightening periods of his life. When Galileo left Padua, he also, amicably, left Marina. But Galileo was not one to take the path of least resistance. If there was no real reason to be restless, he would find one. And he now wanted to return to Florence. Besides, he was tired of the constant round of teaching. In 1609, an object arrived in Italy that was to change Galileo's situation dramatically and completely. It flung Galileo into the wrath of the Inquisition and almost cost him his life. The telescope. Excitement was at fever pitch in Italy, although this first telescope was primitive, no more than an innovative toy. Once in Galileo's hands, however, it was to alter the way mankind perceived his world profoundly and irrevocably. As soon as he could, Galileo got himself a description of the instrument and rushed home to build his first telescope that very night.
The first written record we have of a telescope comes from 1608, the 25th of September, from the Netherlands. It was the Council of Zeeland, and they had been asked for a patent for what was called a spying class at the time. A week later, Hans Lippershey applied for a patent for his looking glass, but it was turned down on account of the fact that these were springing up everywhere, and that it was a very simple design. In 1609, Galileo himself, for the first time, sometime in July, saw a telescope. It magnified about 3 times, but Galileo was actually able to increase this to 30 times by increasing the focal length and cleaning the tubes. Again, a question not so much for inventing something, but seeing the idea and perfecting it absolutely. Galileo was very good with his hands. The problem with the Dutch telescopes was that they showed things upside down, which wasn't so much for a problem for looking at the stars, but it was definitely a problem for looking at ships. This was because they had 2 convex lenses. Galileo used a concave lens and a convex lens, so the object itself looked the right way up.
Galileo developed the telescope, and he developed it for a very precise reason. He wanted to use it for scientific purposes, and specifically to observe the heavens. So he needed telescopes which would give him finer resolution, and he spent a lot of time and a lot of energy and a lot of his own resources trying to develop the telescope until, as he claimed, he developed one which magnified the heavens by 2,000 times, although I'm not sure whether that's an exaggeration or not. Nevertheless, because he wanted to observe the heavens and had discovered things about the heavens that intrigued him, then he had an impetus to refine the telescope. And I think that it's fair to say that his efforts have helped the telescope to develop into quite a precise instrument.
The opportunity for Galileo to make his next step forward was not long in coming. When the Senate was considering whether or not to buy one of these new instruments, Galileo immediately offered to make a better one. To his joy, the Senate agreed to wait and see what he could come up with. Galileo set to work immediately, using the best Venetian glass for the lenses, testing and rejecting time and time again, struggling with the problems of distortion and magnification, until by late August he had a telescope that he was sure would enhance his reputation. It could magnify 9 times. When he presented it to the Senate, success was instantaneous and resulted in him being awarded the chair of mathematics at Padua University for life, together with a salary of 1,000 florins a year.
The popular view of Galileo is dropping balls off the Tower of Pisa. I think the intellectual view of Galileo is as a giant, a man that championed the freedom of inquiry and who championed exact measurement of natural phenomena.
This was just the beginning. Galileo turned his whole workshop over to the production of telescopes in the attempt to make the magnification even better. Inevitably, it was only a short time before he succeeded and had a magnification of 30 times. It was this telescope that he turned excitedly towards the heavens. What Galileo saw through his telescope astounded him. The skies opened up their secrets and wonders. With every new discovery, evidence for a moving earth was presented to him. But the sights themselves were breathtaking to the 17th century observer. In his small volume called The Starry Messenger, Galileo wrote, "It is a most beautiful and delightful sight to behold the body of the moon about 30 times larger, and one may know with certainty that it is due to the use of our senses that the moon certainly does not possess a smooth and polished surface. It is rough and uneven, just like the surface of the earth itself, is everywhere full of vast protuberances, deep chasms, lofty mountains, and deep valleys." Aristotle had claimed otherwise. The discoveries flooded in. The Milky Way was found to be a collection of stars. There were stars never seen before, so numerous, said Galileo, as to be almost beyond belief. And then he found that the 4 satellite planets of Jupiter were in fact in orbit around it. Another nail was about to be hammered into the coffin of Aristotelian theory.
In Aristotle's universe, there was only one centre of motion. This was the Earth. Everything else either revolved around the Earth, fell to Earth, or was pushed away from Earth. The discovery of the moons around Jupiter meant to show that there were 2 centres of motion. This was more in keeping with certainly either Tychonic but also Copernican systems of the universe, whereby the moon would revolve around the Earth and the Earth would revolve around the sun. This was 2 centres of motion. If you have 2 centres of motion, there's no reason why you shouldn't have 3. And so the discovery of the moons around Jupiter, although they don't conclusively prove the Earth went round the sun, almost took away the reason why one should not believe it, that there was only one centre of motion.
When Galileo first observed the moons of Jupiter, he was astonished. At first he thought he was observing fixed stars, but when he looked again, he noticed that those fixed stars had moved, and he spent some time looking at their movement and realised that they were rotating around Jupiter. Now, he never got around to observing and recording the rotations of the moons precisely, and he suggested in one of his pamphlets, The Starry Messenger, that other astronomers should do that. But what he did suggest was that there in Jupiter, with its moons orbiting around it, was a small model of the solar system as he conceived it, with in this case the Jupiter taking the part of the Sun and the moons taking the part of the planets, in particular the Earth.
Aristotle was wrong. Galileo knew it, and he was not afraid to pronounce it to the world. He did so with the publication of The Starry Messenger. It was a bestseller and went into second edition within months. Galileo was famous overnight, his dream come true. Yet, successful, Galileo was no more content than he had been as an unknown mathematician. Not with a huge increase in salary, or the title of philosopher and mathematician to the Grand Duke, and all Europe talking about him. He resigned his post at Padua and returned to Florence. Almost immediately, his studies of the night sky led him to the discovery that Venus must be orbiting the Sun, and not the Earth, thus adding more weight to the Copernican theory of a moving Earth. As Galileo became more open and confident, his enemies became more irate and determined to squash the upstart astronomer. Unaware that a storm of unbounded ferocity was about to break over him, Galileo went to Rome to persuade the Catholic order of Jesuits of the truth of his observations. In this, he was completely successful. He was well received by the Pope, feted wherever he went, had his new instrument renamed as a telescope, and returned to Florence buoyed with his good fortune. In Florence, his detractors had gathered around an arrogant academic named Ludovico della Colombe, and their plan was simple: to let Galileo's defense of his own iconoclastic views do the damage for them.
Galileo was a very arrogant man. He was very proud. This led him into trouble throughout his life. Essentially, he spent almost all of his life defending himself against his perceived critics and people who he said had taken away his ideas.
He was a dedicated scientist. He believed in the power of exact measurement, and that's what drove him. He was systematic, he was careful, he was imaginative. And I think when he was confronted by dogmatism and ignorance, which from his view interfered with the progress of science, I think he became very irritated and quite courageous